YouTube channel. This is Sangeeta, and in today's video I will cover the GSI Prelims syllabus for economic geology part. Okay, only the prelim syllabus I will cover in this video. So let's see the syllabus first. It is the property of mineral deposit, form, assemblage, texture, rock core association, relationship, magmatic, sedimentary, metamorphic, hydrothermal, supergene and withering, okay, etc. So let's start with the very basic. What is economic geology? So it is a branch of geology, okay, which deal with the economic mineral which can be profitable or extracted for the profit of the humankind. ठीक है, हमारे इंसानों के यूज के लिए हम जो मिनरल्स को एक्सट्रैक्ट करते हैं, माइन करते हैं, वो पार्ट जो है इकोनॉमिक जियोलॉजी के अंदर आता है. एंड द मिनरल विच कैन बी प्रॉफिटेबल टू अस, दे आर कॉल्ड एज इकोनॉमिक मिनरल्स. ओके, so these are gold, silver, cinnabar, molybdenite and uraninite. So before moving into detail, let's see the 8 abundant elements in the earth crust. So of course, oxygen is present in the highest amount in the weight percent, which is 46%, and after olivine comes the silicon. Okay, olivine comes first, then silicon. So I remember it this way, that al for aluminium, OCl fe ka na ke mug. Okay, so you can remember in your own sequence, but I remember it like that only. So in this video we will see various rock types. Let's get familiar with it. So peridotite, it is a coarse grained mafic igneous rock composed of olivine with small amount of pyroxene and amphibole. Okay, what is anorthosite? Of course, it is a calcium-rich plagioclase feldspar. It is again a plutonic rock. And what is gabbro? It is coarse-grained, intrusive igneous rock composed of calcic plagioclase and pyroxene. And its intrusive equivalent is called as basalt. What is cyanide? It is a group of plutonic rock containing alkali feldspar and small amount of plagioclase. And its intrusive equivalent is trichyte. What is kimberlite? Kimberlite, it contains garnet and olivine. Okay, and it is found in the volcanic pipes. What is pegmatite? It is a very coarse grained rock, and it is mostly consists of granite or granitic composition it is of. We will see the definition of mineral. So of course, mineral, it is a solid naturally occurring compound having definite chemical composition. So how? Let's see. Quartz have chemical composition SiO2. Hematite, it is Fe2O3, which is an oxide. Chalcopyrite, it is CuFeS, which is an sulfide. What is an ore? So ore, it is the mineral or metal which are present in very high concentration, which can also be profitable to us. Okay, अगर हम उसको mine कर रहे हैं, they should have some profit value. They should be present in high concentration so that we can use them for the current technology which are under the economic conditions. So to be an ore, there are two factors. First, there should be its cost of production. Second, it should have some market value. So ore can be present at the individual part, or it can present in the complex form. Like molybdenum, it is a single metal of molybdenite. But chalcopyrite, it is the copper association with iron and sulfur, as we have seen in this formula. See, it is chalcopyrite, it is copper, iron and sulfide. Also, most ore minerals are combination of metal with sulfur, oxygen and other non-metal. And some metals like gold, platinum, copper, they occur in the native form. Okay, they don't occur in the combinations. So single metal may form many ore minerals, or single metal can be extracted from number of ore minerals. For example, copper, it can occur in the native form, which is cuprite. It can occur as silicate, which is chrysocolla. It can occur as sulfides, which is chalcopyrite, bornite, covellite, chalcocite, or it can occur as carbonates, which are malachite and azurite. So what are gangue? So these are the ore minerals which are usually associated with the non-metallic material. Okay, so these are the not desired part. It means if there is a rock, it will contain ore minerals as well as some non-desired part, which is called as gangue, which should be removed while the extraction of ore minerals, because they are considered as waste. We do not need them. common gangue minerals which are usually present. It is quartz, chert, limonite, calcite, dolomite, ankerite, barite, gypsum, feldspar, fluorite, garnet, chlorite. Okay, so this is the list of common gangue minerals. And these can be asked in your competitive exam, that like which mineral is a gangue mineral, like that. So you have to remember this table. Next, what is tenor? So tenor of ore, it is the metal content of ore. Okay, how much metal content is present in that ore, which is of profit. So they are usually expressed in weight percentage if it is a base metal, and gram per ton if it is a precious metal. So tenor, it varies with the price of metal and cost of the production. For example, tenor in case of non-metallic mineral refers to the percentage of metal content in an ore mineral. So for example, in case of asbestos, agar tenor is 6%, it means the occurrence of asbestos fiber is in the ore is 6%. Okay. What is mineral paragenesis? So mineral paragenesis and zoning, metallogenic epoch, province, they are the important factor for the controls of the mineral localization. Let's see what is mineral paragenesis. So it is the mutual relationship of the time and sequence of the minerals. It means it will tell about the sequence, just like our ancestors. Like my mother is elder than me, and then I am elder than my brother. So this is just like the sequence of a family. So it will tell about the sequence of mineral with the time. Okay. So the individual mineral in mineral deposit of magmatic affiliation are formed in an orderly sequence. Okay. मैं क्या बोल रही हूँ, ऑर्डर में बन रहा है ना, लाइक मेरे मदर मेरे से बड़े हैं, उनके बाद मैं हूँ, मैं अपने भाई से बड़ी हूँ. सो ये एक ऑर्डर सीक्वेंस में चलेगा, और दिस इज अ sequential arrangement. It is termed as paragenesis. What is mineral zoning? Mineral zoning, it is the tendency for certain mineral or ore to be deposited at varying distance from the focus of igneous activity. Suppose if in any area, igneous activity is going on, then the high temperature and least soluble mineral, they will be found near the source. Suppose this is the magma. Okay. So high temperature mineral will found at the source, but low temperature mineral, they will found in the away from the source. Okay, because they need low temperature for its formation. What is metallogenic epochs? So these are the specific period in the formation of large number of mineral deposit. Okay, so in India there are three type of these epochs, or the time period when some important type of minerals has been deposited. Okay, so this is Precambrian, late Paleozoic, late Mesozoic to early tertiary. So let's see. First one is Paleozoic. So in Paleozoic, iron deposits, they deposited in the Precambrian epoch, okay, in the Bihar, Keonjhar, Mayurbhanj, Sundargarh of Odisha, Bastar and Durg, Madhya Pradesh, okay. So these are the places where we found the iron ore deposit. Dharwar, Bellary, Sendur, Shimoga, okay. And the chromite deposit, they also formed in the Precambrian. These are Singhbhum, Cuttack, Keonjhar, Bhandara and Ratnagiri. See about the gold deposit, they are present in Kolar, Hatti, Gadag in Karnataka, Ramagiri, Anandpur in Andhra Pradesh. Okay, so places are written along with that. Vyanad in Tamil Nadu. And copper deposits, these are Singhbhum, Bihar, Khetri, Malanjkhand. So these are just the example of copper deposit in the India. You have to remember this. And these are the example of Precambrian epoch. And we look at the late Paleozoic time, which is Permo-Carboniferous. We see lots of coal deposits have been formed in this era, right? Why? Due to the Hercynian movement introduced. Okay, so what it caused? It caused the mountain building process, okay, initiation of sedimentary era. So this resulted in the formation of rich coal deposits of lower Gondwana age. And these deposits are Jharia, Bokaro, Girid, Ramgarh, Auragarh. These are places in Bihar, Raniganj, Darjeeling of West Bengal, Singrauli of Madhya Pradesh. Okay, so these are the important example. You have to remember this. And in case of late Mesozoic to early Tertiary epoch, we see Deccan Trap Formation. Okay, we see Deccan Trap Formation. And what type of semi-precious metal we found there? We found amethyst, agate, onyx, chalcedony. What is metallogenic province? So metallogenic province is known as the name of dominant specific mineral. ठीक है, तो अगर एक जगह पे जो डोमिनेंट मिनरल मिल रहा होगा ना, तो हम प्रोविंस के आगे गोल्ड लगा देंगे. अगर हमें गोल्ड मिल रहा है एक एक्स एरिया में, इफ यू फाउंड dominant mineral which is gold, so we call it as gold province. If we found in the B place copper in the high concentration, we called it as copper province. Okay, so it is like that. So in India there are various example like gold provinces of Karnataka in Andhra Pradesh, copper province of Shinghum in Bihar. So these are its example. So what is SA value? So SA value, it is the quality of ore, like how much metal is present in the sample, and we do it chemically. Okay, we take chemical analysis of the sample to know that if this is a sample of it is a rock sample. Okay, and some minerals are present, so we will do its chemical analysis to find out how much copper is present in this rock sample. Okay, and this is done basically as weighted average form. Okay, so while using SA value, we can find the grade or over grade of a rock. Come to the tonnage part. It is the quality of ore mineral. Okay, I have to write ore here. It is the quality of ore mineral, which means the mass of ore or quantity of ore present in the mineralized zone. Okay, and what is mineralized zone? It is the presence of ore mineral in a rock, which make it as a mineralized rock. Then comes the term total metal content. So it is the tonnage of ore in tons multiplied by grade of ore in weight percentage or gram per ton. What is cutoff grade? So cutoff grade, it's just like the passing marks in exam. So it means the minimum concentration of metal present in a rock to be qualified as a ore. So here we will see some important ores, like for antimony it is stibnite, okay, arsenic, asbestos, its ore is chrysotile, bauxite ore are bohemite, diaspore, gibbsite. Okay, this has been asked in the exam also. Beryllium, it has ore mineral of beryl. Chromium has chromite. Copper, ore minerals are bornite, chalcocite, chalcopyrite, covellite. Gold, it occurs as native gold or calaverite or sylvanite. Iron, ore minerals are hematite, magnetite, siderite. Okay, so these are the important ore of various minerals. Similarly, in case of manganese, it is pyrolusite. It is also asked in the GSI exam. And silomelane, braunite, manganite. So similarly, you can remember this from this table. Okay, for potash, it is sylvite, kyanite. Okay. For Re, it is besonite, monazite. Okay, this is the formula written here. For sillimanite, it is andalusite, kyanite, sillimanite. Okay. So what are the mineral deposit, or you can also say ore deposit? So mineral deposit, it terms to the accumulation of useful minerals, okay, in an area. Suppose if copper mineralization is occurring in the Balaghat district of Madhya Pradesh, see here. So it is found in the rock which is tonalite and granodiorite, which is the plutonic rock. What are ore bodies? So ore bodies, these are the ore deposit consist of rock bodies enclosing one or more ore mineral along with those natural material which are not ore. Okay, so as you see in this diagram, these black ones are ore body present in these rock. Okay, this is not ore, this brown part, but this black part, it is the ore body present here. So this is Malanjkhand copper deposit showing ore bodies marked by black arrows. What are industrial minerals? So they are the non-metallic minerals. So they are basically non-metallic minerals like galena, halide, phosphorite. This is the example of phosphorite figure of rock phosphate deposit at Jamarkotra in Rajasthan. So let's see the nature and morphology of ore bodies. So ore body, they can be syngenetic deposited or epigenetic. Syngenetic, it means ore deposit which has been formed by the same process at the same time. It means both host rock and ore body, it is forming in the same time. Okay. For example, iron rich sedimentary horizons. But in epigenetic deposit, what happened? That ore deposit they form after the formation of host rock. It means host rock will form first and after that ore deposit will form. Like if there is a rock and it has opening in it. So this is the host rock which is already present, right? And after some time due to any activity, this crack will get filled with some other minerals. Okay, so this was crack was filled by some other mineral and this will form the vein. Okay, so this part will called as veins which will be present in the host rock. So here host rock was already present and after that ore is getting deposited, right? So discordant ore body. So it refers to the ore body which cut across the bedding plane or banding. So these are of two type: regularly shaped ore bodies which are tabular ore bodies. So they are extensive in 2 dimension but restricted in the 3rd dimension. So they are also called as fissure veins or lodes. So what is the difference between the veins and lode? So veins, they are considered to be resulted mainly from the infilling of pre-existed open spaces like I have explained here. There was some rock and some crack was present here, and when the ore get deposited, it will result in the formation of vein here. Okay. And what are lode? Lode is a deposit of metallic ore that fills or is embedded in a fissure or crack in the rock formation. Lodes, some replacement will occur with the pre-existing rock. But veins, they deposit within the layers of rock. Okay, there will be no replacement going on. So vein, they are often inclined and frequently pinch and swell out as they follow up down a stratigraphical sequence. Let's see how. So if you look at this diagram, so this is a vein. So this was a normal fault present here, and this deposition of some mineral resulted in the formation of this vein. So there pinch and swell structure present, giving rise to a ribbon overshoots. Okay, and these are the lodes which are present as shringers. Okay, this golden part here it is written that stringer lode is a deposit of metallic ore which is permeated by many irregular branching like that. What are tubular ore bodies? So tubular ore bodies, they are restricted in 2 dimension, okay, and extensive in the 3rd dimension. So if they are vertical or subvertical, they are called as pipes or chimneys, mantos, or we can call as blanket. They are horizontal or sub-horizontal body. Okay, so here you can see if it is vertical, it is called as chimney, and if it is horizontal, it is called as mantos or blanket. Irregular shaped bodies, these are disseminated deposit. It means they are not deposited regularly. They are irregularly deposited in any rock. See, and disseminated deposit may wholly occur along the closed space wheel net, cutting the host rock, form an interlacing network. So this is called as stockwork. Okay, तो एक नेटवर्क फॉर्म में इसी रॉक में प्रेजेंट है, राइट, एक दूसरे से जुड़ी हुई है, राइट. तो ये एक नेटवर्क फॉर्म में प्रेजेंट है, इसको हम बोलते हैं स्टॉक वर्क. So this interlacing network is called as stockwork. Irregular replacement deposits. So these are magnesite deposits. So again, they are not present regularly, and some replacement will occur. Okay. So these are called as skarn, in which replacement of pre-existing rock, carbonate-rich sediment will occur. Concordant ore bodies, they are the opposite of a discordant one. Discordant one are perpendicular to the bedding, and concordant, they are parallel to the bedding. So they are of two type. They are either stratiform type or strata bound type. Okay. So stratiform type, if they are parallel to the bedding, and strata bound, they can be concordant or discordant, and which are restricted to particular stratigraphic column. Okay. So these parallel bedding, you can see these black ones, they are stratiform deposit, and these which are restricted to a single or particular stratigraphic column, these are strata bound deposit. Okay. Next, we can classify this on the basis of host rock, like it can be igneous, sedimentary, or metamorphic. So sedimentary host rock are limestone, argillaceous rocks such as shale, mudstone. Okay. And this Kupferschiff deposit of Germany is famous example. Our arenaceous host rock, it can be rudaceous, chemical sedimentary host rock. Igneous host rock can be volcanic host rock. It can be volcanic, which is vesicular filling deposit. Okay. Or volcanic hosted massive sulfide deposit. Or it can be plutonic host rock, like Bushveld complex of South Africa. So if we look at the formation of mineral deposit, they can be either primary or secondary. Okay. So primary or hypogene are those which are formed during the original period of metallization, and supergene which are altered by some weathering effects or some superficial processes. Okay. So primary deposits, they are basically endogenous. It means there will be the effect of temperature, pressure. Okay. Magmatic effect will be there. Metamorphism will be there. So endogenous process, they are of magmatic concentration, metamorphism, and hydrothermal. Whereas exogenous, in this, mostly the process of heat or weathering will be effective over here. So they are of weathering or supergene enrichment, chemical deposition, or mechanical concentration. So if you look at this diagram, here nothing but it is shown that this is a basaltic magma. Okay, so magmatic segregation is going on here. See, minerals are getting concentrated here, so it is segregation or separation is going on. And if there is a granitic magma, so the country rock which will be present or surrounding it, it will get metamorphosed. Okay. And this is exogenous, result in the formation of laterite or bauxite. Mechanical concentration, it will result in the placer formation. Okay. Placer, it will found in the rapid waterfalls, potholes. These red colors you see, these are the lodes. Okay. So these are mother lode ore in quartz vein in deposit. So for the formation of, let me change the color of this pen. For the formation of hydrothermal deposit, there will be hot mineral laden water is required, right? And this process result in the formation of mainly epigenetic minerals. Okay. Which means those which form later from the host rock. And these are the various type of hydrothermal deposit which can be tele if 50 degrees Celsius. Okay, epithermal, mesothermal, hypothermal, and these are the temperature range. So what are the origin of solution in the hydrothermal deposition, okay, of the minerals? It can be magma, or it can be metamorphism, है ना? Or it can be rainwater or connate water. And the composition of solution. So mainly the composition of solution is they are in the form of brines. It means they contain some dissolved salt in it like NaCl, KCl, calcium sulfate or calcium chloride. And the salinity, it ranges in the 3.58%. So what are the conditions necessary for the formation of hydrothermal ore deposit? So there should be presence of hot water, presence of interconnected openings, ठीक है. गर्म पानी होना चाहिए, तभी तो वो ट्रांसपोर्ट कर पाएगा और डिसॉल्व कर पाएगा जो भी मिनरल्स होगा. ओपनिंग होनी चाहिए जिसके बीच में से सॉल्यूशन मूव कर सके, राइट. And some type of chemical reaction should be there. So these are the various type of water which can be connate, present originally in the meteoric in the form of rainwater, okay, magmatic water or metamorphic. So cavity filling and replacement are the two type of deposit which are formed due to the hydrothermal processes. So important point is that for the cavity filling deposition, there should be some presence of opening in the rocks, okay, and the metasomatic replacement, there occur the replacement of the originally present minerals in the rock, and the replacement will cause the formation of new mineral in the rock. In general, replacement deposit are formed at the high temperature and pressure. Okay, so replacement deposit they are formed in the high temperature pressure, and cavity deposit they are opposite of it. It means they form at low temperature and pressure. So there are the type of veins which are present in the cavity filling. So it can be fissure vein, ladder vein, gash vein, or stock walks. All right. So this is the example of fissure vein. These are the ladder vein. These are gash veins. Okay, this one. This is stockwork, and these are the saddle reef which are present in this hinge part of the folded region. Okay, they are present in the, like if this is a fold and this is a hinge, so here saddle reef will be present. Let's see. So fissure vein, they are a tabular type of deposit. Okay, so no need to discuss about it. And these are the examples. These are again gash veins. These are segregated veins of auriferous quartz. Okay, this gray part, this is veins. These are horizontal gash veins. These are also veins. This white part is vein. Okay. So shear zone deposit. So in exams, mainly the example of these deposits are asked. Okay. So in shear zone deposit, we see Shingu shear zone deposit. It is the example of shear zone deposit. Stockwork, as I have told earlier also. So stockwork, they are mainly found in the Zawar area, Rajasthan veins. Okay. In the Archean terrain of Barabana area, Singhum, Bihar. Saddle reef, it results when the alternating competent and incompetent rocks are closely folded. As I've told, if there are folds like this, okay, so in the hinge part, you will get the deposition, which we will usually see in the Hatti gold deposit of Karnataka, Vanad gold deposit in Tamil Nadu, right? And this is the example of saddle reef. See, this is a mountain. Okay, and in the hinge part you are getting this white quartz deposition. Ladder vein, this is a type of deposit formed due to the transfer beams, है ना, as you have seen in this diagram. Like in the transverse manner, है ना, one above the another. So that is why it is called as ladder vein. It means step like, है ना, पौड़ियों जैसा, सीढ़ी जैसा. So this type of deposit formed due to the transverse veins or fracture, like magnesite deposit of Mysore, Karnataka, asbestos deposits of Kadapa district. Next is pitches and flats. So these are formed again due to the folding of the brittle sedimentary beds, like iron ore deposits of Beladila, Chota Dongar, Bastar district, Madhya Pradesh. Okay. Breccia filling deposit. The breccia, it has opening or spaces in it, है ना, in between the agular fragment for the deposition of mineral solution. So in those spaces, suppose this is breccia, it has openings. So in these openings, solution can deposit their mineral like Vajrakhor kimberlite pipe in Andhra Pradesh, Paul breccia in Shingbum shear zone. These are the example of it. Solution cavity filling. So certain solution forming rocks like limestone, it gives rise to the deposits of barytes like in Karol limestone of Sirmur district, Himachal Pradesh. Pore cavity filling deposits, it occur in the Zawar. Okay, so Rajasthan is example of pore space filling. Vesicular filling, suppose this is a rock, okay, so it has some vesicles in it which are permeable. It means solution can easily pass through it. So that solution will deposit their minerals here. So these are the amygdules. Okay, these are the amygdules which are the mineral deposit filling extrusive vesicles. Earlier it was like this. It was hollow and solution came and filled its mineral here. So we will find this in Dras volcanics, in Deccan Trap of Maharashtra, Gujarat. Okay. What is metasomatic replacement? So as I have told, it is the replacement of earlier formed mineral by the new one. So for the metasomatic replacement, what are the characters? There should be presence of remnant of country rock, presence of pseudomorph of replacing minerals, and absence of crustification. What are fluid inclusion? So these are the mineral grain preserved sample of hydrothermal solution. So upon cooling, the hydrothermal brines separate into solid. Okay. Upon cooling क्या होगा यहाँ पे एक solid form में separate हो जाएगा और एक aqueous phase में separate हो जाएगा. The temperature at which the fluid was trapped, it can be determined by the heating the sample and measuring the temperature at which gas and liquid recombine. Okay. Next deposit is ore deposit formed by the metamorphism. So we know that metamorphism, it is the alteration of pre-existing rock by the new ones. So and the chief agencies or the chief process are heat, pressure, time and solution. So role of temperature and pressure. So an increase in pressure will cause a reaction to move in a direction in which total volume of system decrease. For example, increasing pressure, it will result in the following changes. Like if we increase the pressure, olivine and anorthite will change to garnet, augite and anorthite will change to garnet plus quartz. Okay. So with increasing pressure, there will be changes like andalusite, sillimanite, it will form to kyanite with increasing pressure. And if there is an increase in temperature, there will be endothermic reaction, which means the conversion of pyroxene to the hornblende. Formation of mineral deposit by metamorphism. So several kind of non-metallic minerals, they get deposited due to the regional metamorphism. And few examples are asbestos, it formed by the metamorphism, right? Formed by the metamorphism of ultra basic igneous rock which are peridotite and unite. Graphite, it formed by the regional metamorphism. Talc, soapstone and pyrophyllite by the mild hydrothermal metamorphism of magnesium minerals like tremolite, actinolite, andalusite, kyanite, sillimanite. These minerals are high grade refractories. Kyanite is formed by the dynamothermal metamorphism of aluminous silicate minerals. Garnet, it will form due to the regional and contact metamorphism. Emery, it is a mixture of corundum and magnetite with contact metamorphism. It means contact metamorphism की वजह से emery is getting formed, which is a mixture of corundum and magnetite. Similarly, all of these are important because one of these has been asked in the GSI exam. So this is the case. Next is ore deposit formed by the sedimentation. Okay. So by the process of sedimentation, iron, manganese, copper, phosphate, these mineral get deposited. Okay. So what are the essential conditions for the formation of sedimentary deposit? There should be adequate source of material, gathering of solution by this solution of other processes, transportation, deposition, and source of material. So material of sedimentary deposit has been derived chiefly from the weathering, oxidation of the foreign ones like iron, manganese, copper. So earth crust, it contain average of 5.6% iron. This means that beneath the earth surface up to a depth of 30 km, earth crust contain about 30 million tons per kilometer square of iron. Okay. What are the 5 important processes which are associated with the sedimentary mineralization? So first one is residual, next is mechanical, then oxidation, supergene, remobilization by meteoric circulating water, and sedimentation. Next, what are the condition? We first see what is residual concentration. So it means the concentration of ore which left as the residue. Means if some movement is going on of some mineral, so कोई भी एक्शन की वजह से पानी हो सकता है, ठीक है, विंड हो सकता है, तो ये मूव करके यहाँ पे आ गया, बट जो रेजिड्यू था वो वहीं पे रह गया, तो उसको हम बोलते हैं रेजिड्यू, ठीक है, विच इज लेफ्ट एज इन सिटू आफ्टर वेदरिंग followed by the transportation. So out of all the 3 mode of weathering, chemical mode is very important for the formation of residual deposit. And what are the climatic condition which are favorable? It should be tropical or subtropical climate. So for the process of residual deposit, there should be climatic condition like tropical and subtropical climate. Relief, it should not be that much great because ज्यादा हाइट होगी तो क्या होगा, फटाफट वहां से वॉश अवे हो जाएगा, राइट? तो थोड़ा एक बराबरी हिस्सा होना चाहिए, ज्यादा रिलीफ नहीं होनी चाहिए, ज्यादा हाइट नहीं होनी चाहिए, और क्रिस्टल स्टेबिलिटी होनी चाहिए. देयर शुड बी नो टेक्टोनिक एक्टिविटी फॉर अ लॉन्गर टाइम इन दैट एरिया, क्योंकि ज्यादा टेक्टोनिक एक्टिविटी होगी तो क्या होगा, अल्टीमेटली जो है वहां से जो भी मिनरल डिपॉजिट हुआ होगा वो हट जाएगा. सो इट विल नॉट बी कॉल्ड एज रेजिडुअल एनीमोर. And important deposits are iron ore, manganese, bauxite, clay, nickel phosphate, kyanite, barite. Okay. So these are the again valuable deposits. And these are the example of iron concentration. You can see them if you want, but they are not much asked in the exam. So formation of mineral deposit by mechanical concentration. So in this, there will be effect of density of mineral grains. Okay. So mineral deposited formed as a result of gravity separation. It is called as placer deposit. Okay. And there should be high density of that mineral, which should be 3.3 gram per cubic centimeter. Also there should be high degree of chemical resistance to dissolution. Okay, मतलब वो घुलना नहीं चाहिए किसी भी चीज से, कोई भी केमिकल से. The common sulfide ore mineral do not form placer because जो सल्फाइड ओर होते हैं वो प्लेसर नहीं बनाते, because वो जल्दी ऑक्सीडाइज हो जाते हैं और टूट जाते हैं. So the requirement for the mechanical concentration is it should have high specific gravity, chemical resistant to weathering, should have adequate durability, should not oxidize or break down by the chemicals, and there should be continuous supply of placer mineral for the concentration. What are the various type of placer deposit? It can be alluvial, means form at the hill slopes. It can be diluvial, it means it will shift down from the hill and present in the scree or in the talus places. Or it can be proluvial or colluvial, it means present at the foot of the slopes. It can be alluvial, means formed by the running water. It can be aeolian, it means formed by the wind. Or it can be beach placer, which formed by the wave action. Let's see in the diagram. See here. This is these deposits, these dotted one, these are the alluvial deposit. It means they are present in the hill slopes. Okay. And these which are left out, these are called as the residue. Okay. The formation of residual in the left and alluvial in the right. Here, this is alluvial type of deposit. Okay. Heavy gold. First, the gold was present in the quartz vein. It was liberated. ठीक है, वेदरिंग की वजह से क्या हुआ, वो बाहर निकला, फिर इरोजन से वो स्ट्रीम्स में गया, ठीक है, पानी में गया, और कहाँ आके डिपॉजिट हो गया, यहाँ पे डिपॉजिट हो गया, है ना. जहां पे भी रिवर स्लो डाउन हुआ उधर इट गॉट डिपॉजिटेड. सिमिलरली हियर. This is also a type of alluvial deposit. See, these are the quartz ribs, yellow one, okay, and इसके पीछे जो है deposition हो रहा है, and this is the movement of water current or anything. यहाँ पे क्या है, waterfall था और जो भी depression था, ठीक है, यहाँ पे deposition हो रहा है. See ये black dotted one. इसमें क्या हुआ, एक मेन स्ट्रीम थी, उसमें जैसे ट्रिब्यूटरी मिली और जहाँ पे थोड़ा कम इफेक्ट हुआ उसका, ठीक है, यहाँ से निकल गई अगर, तो यहाँ पे बेंड था तो यहाँ पे डिपोजिशन हुआ. इट इज कॉल्ड एज पेस्ट्री. ऑल्सो इट अकर इन दी meandering stream also. Next is ore deposit formed by the oxidation and supergene enrichment. So let's see in this diagram. The upper portion, it is called as oxidized zone, okay, and lower portion, it is called as secondary sulfide enrichment zone, and this portion is called as primary unaltered or hypogene zone. Okay, so the lower unaffected part of the ore body, it is called as hypogene zone. Let's read more about it. So portion of ore body lying above the water table is described as zone of oxidation. Okay, and by this reaction, the surface water containing free oxygen with the ore solvent is formed. Let's leave this part. So an ore body thus become oxidized and generally leached off its many valuable material down to the groundwater table. ठीक है, तो क्या हुआ, जोन ऑफ ऑक्सीडेशन से नीचे जो है ग्राउंड वाटर में जा रहा है जो भी मटेरियल था, ठीक है, डेप्थ में जहाँ पे ऑक्सीडेशन नहीं हो सकती है. So this process is called as infiltration deposit. Next is gusan. So gusan, it is made of principally limonite, gangue minerals, and some of the oxidized product of the ore mineral. So in the top most part, we will find the gusans, and it is of limonite and gangue minerals. What are the chemical changes which occur in the supergene environment? So there are two main chemical changes within the zone of oxidation. Okay. First is oxidation, solution and removal of valuable material. Second is transformation in situ of metallic minerals into oxidized compound. So most metallic minerals, they contain pyrite, which rapidly yields sulfur. Okay, so this is pyrite. So it yields sulfur to form iron sulfide and sulfuric acid. Then this is ferrous sulfate, it get oxidized with this oxygen to ferric sulfate and ferric hydroxide. And the ferric sulfate hydrolyzes to ferric hydroxide and sulfuric acid. So this ferric sulfate, it is a strong oxidizing agent and attacks the pyrite. This is the pyrite, FeS2, and other sulfide to yield ferrous sulfate. So the ferrous hydroxide changes over to hematite and goethite and forms the ever-present limonite that characterizes all oxidized zone. So the part played by ferric sulfate as a solvent can be seen by the following. So this is for the, see, it is changing pyrite, chalcopyrite in these forms. Okay. Next is classification of magmatic deposit. So they can be of early magmatic deposit, which are also called as orthomagmatic. Here, crystallization will occur without the concentration, and segregation of early formed crystal will occur. Injection of material concentrated elsewhere by differentiation. So first can be disseminated of mineral is not regular form. It is disseminated. It means separated everywhere. Okay, like this. Segregation in this, the due to the gravity, the crystal, they get settle out in the form of lens or in the form of pods or stringers. And these are the Indian example of early magmatic deposits. Disseminated ones are diamond and kimberlite, Majghavan pipe. Segregated ones are chromite in Noshai, Sukinda area. Okay. Late magmatic deposit, these are those which form after the closing of magmatic period. So here variation of crystallization, differentiation, gravity, accumulation of heavy residual liquid, liquid separation of sulfide droplets will occur. So residual liquid segregation, its example is titaniferous magnetite layers of Bushveld. Residual liquid injection, example is titanomagnetite. Okay. Immiscible liquid segregation, the example is Bushveld, which is very famous deposit of Sudbury, Ontario. Immiscible liquid injection, nickel deposits of Norway. And if you see the late magmatic deposit for residual one, the Indian examples are Hassan district, titaniferous magnetite of Hassan district, vanadiferous magnetite deposit of Mayurbhanj. Okay. So we have to remember the important ones. Okay. So they are asking the famous ones only in the exam. So that is why I am not focusing on the other. Residual liquid injection in the Arunachal Pradesh. Late magmatic deposit of Indian example for immiscible liquid segregation. It is Bell-Button belt of Bihar. Immiscible liquid injection example is Shingbum copper belt. Pegmatite ones, they are formed by the fractional crystallization. See here, this is the pegmatite type in granodiorite body. Okay, here you will see the formation of these residual elements: lithium, beryllium, tantalum. Last but not the least, major ore type of India and their tectonic settings. So stratiform type, they are found mainly in cratons. Locations are Sitamundi, Hassan, and these are the geological ages. Sitamundi is of earlier Proterozoic. Massive sulfide deposit in volcanic association. It is cupiferous deposit. They are found in the island arc, and example is Singhbum of early late Proterozoic. So you have to remember this table. Okay, so I have marked the important ones here. Iron ore, banded iron formation of greenstone belt, Babaudan of Archean early Proterozoic age, porphyry type copper deposit of orogenic belt or subduction zone in the Malanjkhand of age early to middle Proterozoic. Okay, so thank you so much for watching this channel. Do like, share and subscribe. यार बड़ी मेहनत लगती है सबको ऐसा, मतलब इतना फास्ट क्योंकि ये पूरा सिलेबस खत्म कर दिया है इसके बाद नेक्स्ट वीडियो फॉर दी कोल एंड पेट्रोलियम, शायद, नॉट श्योर अबाउट इट. तो प्लीज लाइक शेयर सब्सक्राइब कर देना. और ये कुछ पास्ट पेपर के क्वेश्चंस है फॉर जीएसआई प्रीलिम्स. ओके, तो ट्राई टू सॉल्व दिस आफ्टर वॉचिंग दिस वीडियो. इट विल डेफिनेटली हेल्प यू आउट. सो थैंक यू सो मच. मिलते हैं नेक्स्ट वीडियो में. बाय बाय. बाय.